Okay, in the first question is given that A and B are related by relation M. M is equal to A by B. Here M is linear density. So what is the meaning of linear density? Linear density means mass by length. So the dimension of M will be mass L minus 1. Now it is given that the A is force. And if A is force, then we know force is equal to MA, which is, so for A we can write the dimension as M1 L1 T minus 2. Then is given M is equal to A by V, and we have to find V. So V can be written as A by M. So in dimension you can write M1 L1 T minus 2 divided by ML minus 1, right? So now how much will get? We will get cancel out, M will get cancel out, so we'll get L2, sorry for this, so we will get L2 T minus 2. This is dimension of V. Now the question is, which dimension is same as this L2 and T minus 2? First is pressure. Now we know what is pressure. Pressure is force into area, force per area, and in force we know there is a mass quantity, right? And if we are dividing by area, so mass will not get cancelled. So in pressure there will be a mass quantity. So this dimension cannot be same as pressure. Now in case of work, this is option B. In work we know force into distance. So even in this case also, force contains one mass, whether so the dimension of the work will have some force, the mass quantity, where in this case there is no mass quantity. Now let's see latent heat. Okay, we'll check latent heat, and then we'll see whether it is none of these or not. Now what is latent heat? Latent heat, we know the amount of heat needed for unit mass of substance to do the phase change. So you can write Q is equal to ml. M is mass, L is latent heat. Okay, now from this we can find the dimension of L. So L can be written as Q by M, and Q is heat, and heat the dimension of heat and work is same. So we can write the dimension of work, that is force into distance, and in case of force it is M1 L1 T minus 2, and distance is L by M. So how much will get? will get cancelled, and we will get L2 T minus 2. Hence the dimension of latent heat is same as the dimension of V. So for this case the correct answer is latent heat. Now next, move to the second question. In the second question is given the mechanical equivalent of heat. What is the mechanical equivalent of heat? Now we know the mechanical equivalent of heat and work. There is only constant. This is J, we also know as it is 4.6 joule. It is a constant value, right? The value of 4.6 joule is a constant, and we know the dimension of Q and W are same. Hence the mechanical equivalent of heat has no dimension. So the correct answer is no dimension. It is dimensionless. Now let's move to the third question. In the third question, it is given R and L reference resistance and self-inductance respectively. Which of the following combination has the dimension of frequency? Now the first question is, we know frequency F for RL circuit is given as when. Okay, there are two ways of doing this. First, find dimension of resistance, and then find dimension of L, and then divide them to get the result. The second is by just doing the linear calculation for the units, you can find this answer also. So we know R has unit of ohm. Okay, and also we can write the reactance XL. Reactance due to inductor can be written as omega L. So here omega has the frequency and L is resistance, and this reactance total has the unit of ohm. So what we can do here, we want to find, so omega L has same unit as R, then omega has unit of r by L, and we know omega is 2 pi f, right? That is frequency. So in 2 pi there is no unit, so f is same as r by L. So from this we can conclude that the dimension of frequency will be same as the dimension of r by L. So from this we can find this answer. There is also another way. You just have to find r, the dimension of r, and you can find the dimension of r from v equal to ir, right? And you can find the dimension of L from EMF is equal to L di by dt. From these two you can find L dimension of R and L, and then from that you can find this one. Okay, so now move to the next question. Out of the following pairs, which one does not have identical dimension? Okay, let's see. Now moment of inertia and moment of force. Okay, so in the moment of inertia we know torque is equal to I alpha, right? Here I is moment of inertia. And alpha is angular acceleration. So moment of force, what is moment of force? Moment of force means force into distance, that is r cross f, that is known as moment of force. So that is moment of force is the same dimension of torque, means moment of force and torque are same. Okay, and here they are asking moment of inertia and moment of force. So moment of inertia and moment of force have no, obviously they have different dimension. Then work and torque, we know work is equal to force into distance. Again we know torque is also force, distance into force, so they both have same dimension. Angular momentum and Planck constant. Okay, from both law we know the angular momentum of the orbit should be integral multiple of Planck's constant, right? From that you can see that Planck's constant and angular momentum have same unit. And then impulse and momentum. Okay, momentum is like dp by dt is equal to force. And what is impulse? We know impulse is f into dt is equal to dp. That means the impulse and the momentum has also same dimension. So the correct answer will be this one, the first one. Moment of inertia and moment of force does not have same dimension. Now let's move to the next question. In this question it is given S is equal to A plus BT plus CT square. S is a measure of in meter, S in meter, that means the distance, and T in second, this time. The unit of C, how much will be unit of C? Now we can see S is equal to A plus BT plus CT square. Now we know only same type of quantity can be added, right? So if S is distance, that means A is also distance, BT is also distance, and CT square is also distance. Now again T is time. So if BT is distance, then V is equal to distance by time. So from this we can find dimension of V is L by T, that is L T minus 1. Now again CT square is also distance. If that is the case, then C will have distance by time square, so that is L T minus 2, right? So the dimension of V will be LT minus 1, dimension of L will be T minus 2, but they are asking the unit of C. So what is the unit of C? Meter per second square, right? Meter per second square. This is the first option. The correct answer will be first option. Now move to the next question, that is sixth question. The damping force of an oscillator is directly proportional to the velocity. Okay, force is proportional to the velocity. The unit of constant of proportionality is how much? Okay. So damping force of an oscillator is directly proportional to the velocity. Damping force is proportional to the velocity. The unit of constant. Okay, so if it is directly proportional to the velocity, then you can write F is equal to some constant K into V. Now they are asking us to find the unit of constant of proportionality. That means V can be written as, sorry, K can be written as F by V, right? Now this force, the unit of force is kg meter second square, kg meter square second square, right? And the velocity is meter second inverse. So from this you can write kg meter second inverse. So the correct answer will be kg into meter second inverse. That is the first one, right? Now move to the next question, that is seventh question. Which of the following is not represented in correct unit? Okay, let's see. Stress by strain, Newton per meter square. Yeah, right, that is correct. Energy, kg meter per second. Yeah, maybe. Surface tension, Newton per meter is correct. Pressure, Newton per meter square is correct. Energy, let's see energy. Energy means, okay, work, and the work is force into distance. So force into distance means kg, force is in kg meter second minus 2, and the distance is meter, so it should be kg meter square second minus 2, right? But here it is given kg meter per second, so it is not a correct answer. So which is not given in the correct unit, it is the answer C. So energy is in kg meter per second, which is not correct. Now move to the 8th question. The frequency of vibration F of mass m suspended from a spring of mass constant k is given by the relation F is equal to C m to the power x k to the power y. Where C is the dimensionless quantity. Okay, C is dimensionless quantity. The value of x and y. Okay, if this is dimensionless quantity, just ignore this one. And here is given that okay, frequency is given. The frequency means its dimension is t minus 1. So t minus 1 is equal to m is mass. Okay, so m1 to the power x, and k is spring constant. And what is dimensional spring constant? We know F is equal to kx. So we can write k as f by x, and we know the dimension of f is m1, L1 t minus 2, and x is L1. So how much will you get here? We'll get m1 L t minus 2. So you can write m1 L t minus 2 to the power y. So from this we can see that t to the minus 1, sorry, this is t to the minus 1 is equal to m to the power x plus y, and L to the power minus 2y. Okay, sorry, this is my mistake. Here I have done a mistake. This should not be L, this should be T. It should be T. So here it is not L, it's T. So here it is again T to the power minus 2y. So from this you can see that x plus y equal to 0 and minus 2y equal to minus 1. So from this you can get y equal to half, and if y is half, then from this equation you can get x is equal to minus half. So the correct answer is this one. X is minus half, y is half. Which one is that? Option D. Okay, now let's move to the next question, that is question number 9. In question number 9, it is written that a physical quantity having the dimension m minus 1, L minus 3, T3, A2. Okay, so what you can do here is, see, I want to find the unit of resistance, and I know resistance R is equal to V by I. So what is potential? Now we know potential is potential energy divided by charge, right? So, and potential energy has the dimension of work, that is mass length square T minus 2. What is the dimension of charge? Charge can be written, see, we know dq by dt is equal to I. So in place of dq I can write I dt. So here the dimension will be how much? Ampere into time. So here I can write ampere into time. So I will get Okay, I don't want to write this one like this. So I got v1 is equal to m1 L2 t minus 2 by at, and here you'll get like this one. So I can write r equal to, in place of v I will write m1 L2 t minus 2 divided by at whole divided by again I, which is a. So how much it will be? m1 L2 t minus 3 a minus 2, right? So m minus, okay, here it is given m minus 1 L minus 3 t3 a2. So it is something looking like it opposite to the resistance, right? And if it is opposite to resistance, then what would it would be? It would be like conductivity. Okay, like resistance, the opposite of resistance is conductivity, right? It is something like that. And from this you can see here there is L2 where it is minus L3. So you can say that electrical conductivity, what is conductivity? Conductivity, it will be depends upon the distance also, right? And it's like it is independent of distance. So you can write uh, inverse of resistivity is conductivity. Okay, so by seeing this you can see the answer will be this one, electrical conductivity, or else you can try to write that formula and you can just derive it. Okay, now in the next question you can see in the 10th question it is given that v is speed, r is radius, and g is the acceleration due to gravity. Which of the following is dimensionless? Okay, so we know v has a dimension of L t minus 1, r is the dimension of radius is equal to L, and acceleration due to gravity has dimension of L t minus 2. Now try to do trial and error. And okay, so let's say g, okay, in every option, in the most of the option g is at the okay, first thing is that, see, we have to cancel everything, right? So if I want to cancel the time part of g and the time part of velocity, then I guess that it is sure that if v is in the numerator, then g will be in the denominator, and if g is in the numerator, then v will be in the denominator. Here you can see that in every option v is in numerator, right? So g will be in the denominator. So let me say g. Now if the g is in the denominator, now I want to cancel the time part, is t minus 2, and in velocity I have only t minus 1, so I need to do the square, right? So v square. So if I'm doing v square by g, then I'm getting that the time part is getting cancelled, right? The time part is getting cancelled. Now I have to cancel the length part, right? Now in g I have L, okay? In g I have L, and if I'm writing v square, I'm getting L square. Okay, when I'm writing v square, I'm getting L square. So in the denominator I have 1L. So again, if I write R in the denominator, then I'll get 2L. So here you can see, so in v square we'll get L square t minus 2 divided by, for R we'll get L, and for z L t minus 2. So it will become dimensionless, right? So the correct answer will be which one? This one, v square by rg. Good. See you in the next video.